Hello, good afternoon. I am looking forward to continuing playing around with evolutionary coding. Specifically because I learned something new this weekend. I think it's going to help us, although who knows? Hopefully it will. Albert, hello. How's your day been going? So I read through a little bit of the Nature of Code book, which I then forgot to bring back into here. I left it upstairs, and it had some ideas, and it's like, okay, I think this will work. And then I went to Dan Schiffman's YouTube channel, The Coding Train, and watched through the first two videos in the the neural network playlist, which is a playlist for the Nature of Code series. So basically, those are like the videos that he made on his stream that coincide with the book. So I didn't go very far because I want majority of this to be, exploration times. That, I guess that means hat time. But I did get far enough in to sort of see, is like, oh, okay, the basic neural net, because that's what I needed to do. Is like, okay, what's a basic neural net? We're going to add in a neural network to our individual. So in the bot side to play the game, what does that look like? I couldn't remember. So watching through it reminded me, like, oh, right, we did learn that from the book that shall no longer be named on this channel. You've been finding played a bit of Satisfactory, and your CPU is now busy calculating primes, and your network card is busy helping censor. Nice. Nice. Excellent. Well, it sounds like you had a nice productive day. I spent most of my day working. This morning we made some progress on the Git project, and now we're going to hopefully make some progress in evolutionary programming. Need to find something for your graphics card. I mean, you can make a game, or you could render stuff. Render a video or something. That would use a graphic card. Or you can learn CUDA and write your programs for your graphic card. Okay, so I basically checked and got this up on my own personal GitHub, and we're going to basically follow this. So I'm going to try to be better about choosing when I wear the hat, because I kind of want the hat thing to also be a symbol that I am more likely wrong than right when explaining things, and that's okay. It's part of the learning process, right? I have to make assumptions, and then we have to test it, and then we find out whether or not we're right, and then once we get there, we'll we try all again. You just rinse and repeat over and over and over again. So here's my understanding so far. And this is mostly from mostly from memory, from the deep learning book that we read, the first 6 chapters of, and then it was the deep learning book, and then also watching some coding train videos on this. You're thinking of calculating primes, then using the CPU to generate onion addresses. You could also, if you learn this neural network type stuff, you can do gaming things, and that will use the CPU and GPU, which will be fun. But okay, so I created the most basic of neural network type things, and then I sort of integrated it together with GGEZ. So we have basically GGEZ here, just basically something super, super, super simple. And our bot is in the neural network here. So there's this idea of something called a perceptron. And from what I understand, and I hope that if there's people who actually know what they're talking about, they can correct me either here live or in comments. Use your GPU to generate AI images or play Satisfactory. I mean, I guess you could also make games too. That would be a fun use of GPU time. Okay, so the way I understand it is that we can think of a perceptron as a neuron, and it perceives something. So I don't know if perceptron is actually based upon the language, like the English language of like perceiving or not. I didn't actually look it up. It sounds right. So my brain is like, ooh, maybe that's what it is. Maybe yes, maybe no. It takes in data. So whatever, it takes in stuff that it's seen, and then it's going to apply weights to it. The weights are where magic happens. And then it's going to calculate an output. Now, a deep neural network, so deep learning, is all about multiple layers of weights and multiple sort of like networks like working together. In this case, this is the simplest that we can possibly get. We have basically just two inputs. We have our perceptron, or sorry, the perceptron, the entire thing. We have our two inputs. It applies these weights to it, and then it uses this function, this activation function, to convert it into the thing that we want it to be. Now, in this specific case, I made this between a number of -1 or 1. That's it. So it could be like 0 and 1. It could be something else. Basically, after the weights are done, that's generally what we're going to get, is usually a number between 0 and -1 and 1, but we might also get a bigger number than 1 or a smaller number than -1. This is making sure that we like sort of normalize what our output is going to be. This is my understanding of it. The weights, we start, in this specific case, I'm starting random, but this type of thing allows us to do what we see other like sort of bot makers do, where like, okay, my bot doesn't know what to do. It doesn't know whether or not to press the button or not. It doesn't know what that means. It's like, this is, I think, what they're doing behind the scenes. Most of them don't share their code, or when they do, I am fairly new to looking at them, so I haven't like investigated too much. But this is the idea. So I'm going to put that over here as a reference, and we're going to recreate that over here in ours. So what I'm thinking of doing is creating, let's see, if we go to bot, I want to create a new individual, but we're probably going to call this maybe like an NN, so a neural network individual. Let's do that. I'll do all the my CD stuff down here. So let's see. Okay, we have our game info individual, our library. Okay, so I'm going to create a touch NN individual. Okay, so we're going to imagine, I guess, like let's create this pubstruct, impl. Okay, so we're gonna have new. Let's also see what we need from the individual too. So I'll need this as well to sort of make sure it works with the system that I'm working with. And then eventually we could potentially have like a very simple individual like this, and then also a neural network individual, and then maybe use traits to sort of like allow it to be used in the network itself, or in the genetic algorithm, genetic evolutionary algorithm. Okay, so this has what it's planning on doing, and I don't know if this is right or not. So let's think about our simulation. Our simulation is going to be, and then that reminds me I should quit the one I was using for the starting soon screen. The simulation is going to have our ball moving up and down, and then we're going to be on the left-hand side. So our individual is going to be on the left-hand side, and it's going to be aiming at and then firing a shot at the ball. Okay, great. I realize that if all it can do is come up with a number between 0 and 1, we probably want to like simulate keyboard presses instead of like an actual coordinate for it to click on. So what that would mean would be, okay, let's imagine that we have a gamepad to press. We have like press left to aim left, right to aim right, and then, you know, trigger to fire a shot. So it should be able to do 3 things, which means we need 2 perceptrons, one for aiming because we can only move left or right at the same time. So that's really one action, is which button do you, like which direction do you press the button, left or right, or none at all. So that could be 0, left or right. And then fire would be the other. So we need those 2 perceptions to make 2 individual guesses based upon the information. You already asked, but you didn't hear the answer. What is GGEZ? GGEZ is a game, is like a simple game framework in Rust. It is based on Love 2D, which is a game framework in Lua, which I actually like a lot. I haven't programmed in a while, but I did a bunch of like sort of art with code videos way back in the olden days of the stream with Lua and Love 2D. Has it any relationship with, is that duck? What is that? Is that a duck or a goose? I don't think so. Probably not. I think it's literally like good game made easy. I don't think so. I don't think it has any relationship with the geese. Oh, GZ, like that. No. It's the website for it is quite simply good game easy. Like it's literally made for that. So it is based on the Love 2D game framework, which is a great framework if you use Lua. Love 2D is its own thing, but once upon a time, Love 2D was based on processing, which is a framework for making animations, videos. P5.js is essentially a JavaScript version of processing. So basically a lot of, they're all sort of like there's cousins to that, or like distant second related cousins, something like that. Anyways, so GG, I really like this because basically you just get the same thing you get with processing. You get a update and you get a draw. You can get things to help with draw. It's like super easy to get into when you're trying to build just basic animation type stuff. So here's what we got right now. This is what we got. We got our bots all firing. So we got 100 of them. They're all firing shots. They're trying to aim for this ball, but it's not really working too well. So we need to fix that. We need our individuals to be smart. So we need them to think of 2 things. You've not been able to make Twitch alerts work no matter how hard you try? It's been working for me. I turned sound off for most of them. Like I think some of the bigger ones like make a sound here, but like for just normal follows, just a little thing pops up. Trying to be out of the way. Okay, so let's see. We need, okay, so we're going to store the weights for this. And we have two different things that are happening. We have the, I guess like, okay, what are the inputs? We do the weights based upon the inputs. Because you have to have n, for n inputs, you have n weights. So it has to be a 1-to-1 ratio. So in this case, we know where we are, so our location, and we know where, I guess like where we're aiming. So the current aiming, probably we should do that in rotations, like in radians or in angle, like one or the two. And then we also know where the target is, and it's okay, let's let me figure this out. Okay, so I'll do, so weights is going to be an F32, and it's going to be some number of these. Let's just say 4 for right now, but I'll have to come back and revisit this. So when we know when we know how many weights we need, we'll put them in here. Okay, so that creates a new one. Oh, you know what? And I'm actually wrong about this. So we have the, oh yeah, okay, hold on. I think I'm doing this wrong. We need 2 perceptrons. Okay, hold on. We need 2 perceptrons. So for each choice or decision, unique decision that needs to be made, we have its own perceptron. So basically its own neuron to do. So we need 2 decisions, right? Aim left or right, and then also fire. That means two neurons, which means I'm doing this wrong. Let me, so instead of NN individual, let's actually just turn this into a perceptron. Okay, so let's not do a weight count like this because we don't actually know. It might be different decision things that are coming in. Okay, so we're gonna have a perceptron, which means let's actually just make this a vector. of F32, so we can handle any number of these. We'll have RNG and then the weight count. So the number of inputs that are going to be coming in. Should we, no, let's. So that could be like a U size. Ooh, can I start it off with the vector? I don't remember if that lets me do something like this. And then oh, it's very unhappy with me. Okay, so we have the perceptron. Oh, yep, that would do it. Okay. I think this is working. So basically we create a vector with the same with the expected input count that we're going to get. And then we just store these away. Okay, so then if I wanted to use this in our individual, instead of storing all these things, we would store the two perceptrons. The real Enrico, hello, how are you doing today? Is this burn? I have no idea. I've never used burn, so I have no idea if that link is the real burn or not. Okay, so we're gonna have we have the turn left or right, like, so we have the rotate. Rotate perceptron is gonna be a perceptron. Probably making these do their own thing is probably better. I also don't know if this should be clone and copy. I'm gonna see if I can get rid of the bare minimum. Okay, so perceptron, you need to implement debug. Okay, so we have our Burn is a new comprehensive dynamic deep learning framework built using Rust with extreme flexibility, compute efficiency, and portability. Yeah, so I have no idea. I've never used any of the machine learning, deep learning frameworks. So maybe once we figure this out, it might be interesting to try to use one that's actually like a library meant for it, as opposed to just building our own thing, which is kind of what we're doing here. Now this is simple enough because it's like one level, like it's not deep. So we're not using deep networking here or deep learning because it's just one level. Deep learning is like multiple levels of machine learning, sort of like that, multiple levels of the neural networks. So we're not taking the output of a perceptron and handing it to like more network type stuff, which I am not really familiar with the right words to use for those. I don't think that they're more perceptrons. I think it's a single perceptron that could be deep, but I don't know what the right words are. So sorry, everybody who's sort of probably frustrated with that. Okay, so an individual. So I should probably have the thing that's using this hand us RNG. I mean, I'm creating it here, but we're creating a bunch of these. So let's just do that. And then I want okay, so we hand it RNG, and then how many inputs are we going to give it? So we had already decided we have our location. Our location, each thing would be like one thing. So like our location XY, so that's 2. Our rotation, that's 3. The target location, 4, 5. And the target velocity, 6, 7 things. So that'd be 7. Are using a rectified liner unit to smooth out the results. I have no idea what that is. I am super new to this. I've done a tiny bit of deep learning before in order to train a Pong bot to play. Oh, linear. I don't know if it's a rectified linear unit or not. I am using I'm going to be using an activation function just to turn something into probably a -1 to 1, or maybe just turn it into like -1, 0, 1, and then turn that into a enum that we pass back out. So yeah, I think that's called a sigmoid function. I'm not 100% sure though. Again, I'm probably wrong with all the words that I'm using. Okay, so let's see. This is rotate, perceptron, and fire perceptron. Okay, so we start with you. This is what we have. Now, you are upset. Come on, go references. Oh, I can't even do that here. I think it would be in the library here. Zilby, want to come join? Hi. What's up? Okay, so self-population clone. Okay, so you do need clone. So individual, you do need clone. And if you need clone, you need clone. Okay. So, okay, population size. Let's go back to only like 10 again. Population, we have create the population. We do all this stuff. All this is fine. Okay, so this is like play one turn. And we tell the individual to play. Okay, and when we create the population, that's in here. Okay, so you're yelling at us now. So I need oh yeah, I need to pass it that. Okay, then that makes you happy. Let's not worry about any of the problems as an individual. Okay, so individual does need a score. Okay, so individual. So we have our score, and it's going to be between 0 and 1. So we're going to start you all at 0. Oh, it needs to be public. Shandu, hello. What the hell is neural nets? Neural networks. Is it neural or neuro? Oh, I misspelled that, didn't I? It's supposed to be neural networks, isn't it? Oops. Hold on. Let me fix that. I misspelled it twice at least. That's, you know, consistency, right? So neural. I was thinking that something felt wrong about that. Okay, neural networks. Fixed it. Also, hello, how are you doing today? And also Mr. Swez, hello, how are you? Did I do the same thing wrong with Twitch? I bet I did. Neural. I mean, I'll add the go live message, but it already went live. So everybody's going like, what the heck is Brooks talking about? He has no idea what he's doing, which is not wrong. Okay, so we have our... Okay, so we'll get back. We'll update you as we get to there. Okay, so we have our score. Now, okay, so this is like when we create a brand new perceptron from nothing, then we get a rotate perceptron and a fire perceptron, and we get a score. And that's it. Yeah, I am. So I've actually been streaming on Twitch for a pretty long time, and then recently with the new rule change, I'm able to stream on YouTube at the same time. So it's basically a dual stream situation. And yes, this is Rust. Nice Zillage, Helix setup. So pretty. Yeah, it is nice. I like it. You're doing good? Awesome. That's good. I'm doing pretty good. One more week, half a week almost, till the end of the year, which is really nice. I can't wait. Next week things are going to be better, I think. And I can't wait to tell you, but I can't do that right now because I don't know the full details yet. And so I don't want to set expectations that are not right. Okay, so when we get when we create, okay, so we have new, and then also we have parents creating it. So we have parent 1, parent 2 with a mutation chance, and then the RNG being passed in. Okay, so here's gonna be interesting. So in this case, the only thing that we can mix around would be the weights, right? Now, how would we do that? I want to... Do I want to just say the rates for like one parent's rotate perceptron are mixed with the fire perceptron? Like, how do we want to handle this? I can just like swap those back and forth. Or do I not have perceptrons at all and like just everything is kept track in here, which is maybe more genetic programming, like closer to genetic programming then? Okay, so I know that we have seven inputs and 7 weights. That's not an even sort of swapping thing, is it? I think we should we should have the perceptrons sort of combined together. Does that mean that this knows how perceptrons work? Okay, so I kind of want to, in here, I want to create a new perceptron from 2. So I want to do the same thing that we have here. So new from like parents. So I don't need the RNG, we just have parent 1. It should have the same number of weights. Because they have to, right? Because they're the same parents. So we could throw in a crash just in case they don't. So if we can do an assert, right? So an assert equal that parent 1. So you need to be public then, don't you? Okay, so if they're not the same length, it's going to crash, which is going to let us know that we've done something wrong. Okay, so in that case, I want to take the first half of the weights. Okay. So our weights are going to be the first half of these. So I want, let's say we take the first half of parent 1's weights. I don't know if it matters that much. So parent 1 weights, and then I want 0 through okay, 0 through that. Oh, but it's a double divided in half. So I want like half. Okay, so you go until half the weights. And then I need to turn you into a vector. So that goes to the end, right? I probably want to assert that, okay, so let's store these. I actually don't know if this needs to be public. It might not need to be. Let's do an input count. Okay, so just make sure that they're the same sizes. And then, okay, so we have half weights, length. So then in this case, okay, so that's instead of length. Okay, make sure those are the same. We get our input count, divide that in half, so it's half. Half the input count. Weights, okay, so parent 1, weight 0 through half the input count. Turn it into a vector, extend those weights with half the input count into the end of parent 2 weights. And then we're gonna return a self with the weights. Okay. What are you upset about? F32. Do you need to be... Right, okay, we just do that, and then self. Okay, so we're gonna have weights, and then the new input count. Okay. So this allows us to now get our weights sort of swap around. So we use half them around. Mickey, hello. How are you doing today? Okay, so I want to create perceptrons based upon this. Okay, so I want the 2 perceptrons. So I'm gonna do it for both, right? I'm gonna say rotate perceptron. Oh, that would be interesting. I could do like rotate perceptron from parent 1 and fire perceptron from parent 2. I actually kind of like that a little bit. Yeah, because then we keep all this weird genetic stuff out of here. Okay, so I'm gonna rip all this out. Go into the end. There you go. Okay, we didn't need that anyways. Okay, so we're gonna do let our rotate perceptron. So you have the rotation of your parent 1. And you have the fire perceptron of your parent 2. Okay. Then we'll do let our individual Let's see. Fire cool. Perceptron. Okay, what am I missing? Oh, and score. And you have a terrible score. You have 0. Okay. Good to go. You have a score right here. Oh, with that weird B that we added in. Yeah. Oh, we'll get there. Okay, that's all an individual still. No other things. Okay. Albert, heading to bed. Well, have a great night. Thanks for stopping by and saying hi. Okay, so this is our new from parents. Now, okay. Then we have a chance of mutating. That's okay. In mutate, we have a couple different things. So I could reach in and just update one of the weights to be a random number, or I could just reset the perceptron to be completely new. Either way, I think is valid. Oh, but we're not doing that yet. This is new from parents. Next is update. Okay, update. So we get our bullet distance to target. Okay, so we figure out how close we got. And then we set the score. Okay, so bullet to game info, target size, bullet. Okay, so I think this is working because we have the score updating properly. And then we have play. So we have this game info. I could actually just like simply throw in the thing, like the specific things that we want. Let's try that to be a little bit more explicit, and then we'll wait until Rust Analyzer yells at us about too many arguments. Okay, so in this case, for play, we're gonna have our position, so our like position. So I guess we could just do like our X to our Y at 32. We're gonna have our rotation. Oh, is that Clippy that complains? For some reason I thought that was Rust Analyzer. So our rotation, which is an F32. We have our target X, F32. Target Y, F32. We have our target velocity X, F32, and target velocity Y, which is an F32. We should probably turn that into a struct later. But okay. So we're not going to do any of this stuff. Now this is like trying to come up with a guess. What we need to do is basically now like get the guess from the bot. And then in mutate, okay, so we'll to do this. Let's make this happier. So we'll also throw in a to do here. Okay, in the main game, when we hand it this, we need to hand it all this information. So that's fun. Okay, cool. Multiple arguments are missing. So we have our info, populate. Okay, so we have our population, so we have our individual. But then do we have like where we are? I think we do, right? I think I want to redo some of this too. Because we should all start at the same location to make this fair. Yeah, Rust Analyzer would forward the complaint to you, but I think that I turned off... I think for some reason I turned off Clippy on my Helix, so it probably won't tell me that. So, okay, I need my XY. So, hub, just we'll do our X. So, player X. I mean, this can be a vector, right? So, oh, that's it. We have an entity. That's what it is. So, we have a player. Oh, right. I was trying to like do this with like some special thing. It's a vec individual. Where am I? This is in logic. That seems wrong. Okay, create the population. Wait a second, where am I? I'm in the wrong place. I want to be in U. Oh, this is it. Okay, so we have our players, a vec entity. That's what that is. Okay, got it. Send in U. Here we go. Okay, here we have all of our stuff. So... okay, if we're running, look through all the bullets, which is our entities. So we have to, all of this is going to change too. I wonder if I should just rip this out. Jim, hello. How are you doing today? We are beginning the journey. So we have yet to run into any major issues, but that's also because we have yet to run this. So... I think, okay, so we're looking through, I kind of want to change this to like, oh, no, wait, we do have two different things. So hold on, bullets is right. We loop through all the bullets and we're zipping in the players. Okay, and then we zip in the bot population. Okay, got it. So we got two of those. So here's our bullet. We have a player and an individual from, okay, there we go. All right, so if the bullet is alive, we update the bullet. We calculate the distance to the target for the bullet. If it's in the target, or if it's out of the arena, we basically make it not alive anymore. We then figure out the game info. So we're gonna skip this for right now. I mean, I probably should just keep this in here because it's a nice way to deal with this. So what is this? 1, 2, 3, 4, 5, 6, 7. Oh, we have bullet speed too. I don't think arena size makes any sense. Okay, hold on. Let's go update you. So position, RXY. Off-topic question. Does anyone know a simple CLI program that just displays terminal keyboard events for debugging? I don't know any by default. Not off the top of my head, unfortunately. I mean, GGEZ, what you might be able to do is look into GGEZ's source code to figure out how it does the keyboard events type stuff, and then just like create your own app that just uses the keyboard events. That might be good enough. We don't need arena size, so we need target position, the target velocity. We don't need target size. We don't need bullet position. It might be good to have the bullet speed, right? So this was what? Oh, and we have our rotation. So pub aim, our aim rotation. Oh, this is gonna be a thing. Okay, hold on. If we go to entity, you need a rotation here to store this. So if we start you at 0, so many things. Okay, so we don't need you anymore. I am shocked this is not yelling at me. Oh, it's probably because there's so many other errors here. Okay, so in update, in individual, we have our, oh, you do need that. Okay, fine. You do need all of this information. So let's just add in. Okay, so play. Let's go back to this and just say, okay, you take in, we'll just take in the game info. It's just easier. Cannot move out a parent. Okay, so I want to, then I'll just clone you. Yes, I know. I'll get to it soon. Okay, so we need, I need the game information if we're going to hand it for this and for this individual. Now, what file are we in? I should not have opened up. Okay, hold on. I think we're in this one, right? Yeah, we're in this one, and it's yelling at us saying, hey, okay, play needs this game info, right? So we need to hand it a reference the game info. You're never read. Okay, we'll get to you very shortly. Okay, to make the code, to make this red, we're gonna have to do a guess. So that would be the next thing, to do a guess. The way that neural networks work is that you have the incoming stuff, and then each incoming thing gets multiplied by each weight. And then this one's pretty simple because there's a 1-to-1 ratio. So I want, is that right? Does that what I have written down? It's loop through the weights, and for each weight multiply the weight by the inputs. I actually think I did this completely. No, okay, I did this right. Okay, so here's what I have, and this I pulled this straight from Coding Train. So make a guess. We're gonna have self. We have the inputs, which is gonna be a slice of F32. So we can actually this will be nice. I can't do this as a slice like this because it's dynamic. I can't say that I know that the weights are going to be some certain amount. I can't say something like self dot input count here because we don't have a self yet. Oh, that would have been so cool if I could. I would have to like do a macro to create like a very specific perceptron for that, but I don't think we can. So instead, we're going to have to make this just an array slice of unknown size of F32. And that's it. And then we're going to return something. So let's see, sum. So we start with nothing. We then loop through our weights. So then I want to reduce this down to a single thing. And I can zip together the weights and oh no, I don't want to do that because I want to do everything together. Okay, so let's do this. So index or weight. Okay, so we have the index and then the specific weight, and then I want to increase sum. So sum plus equals by, so each input, so input of index times the weight. Oh, Albert, you figured out what to do with your GPU. You're gonna heat it up with burn. Nice. I mean, that's not too bad. 50 times 5 is not too bad. I've seen much worse. So hopefully that shouldn't take you too long. Let's see. Okay, some inputs, that stuff, and then we have to. Okay, so we have to activate the sum to be like whatever to match the output. Return the output. So we'll do that. Okay, so we have to guess this. Now we don't know what the guess is supposed to be, right? So we need to we probably want to return this as a number between -1 and 1. That probably makes sense. And we can return it as I might want to do it as 3 numbers. So like -1, 0, and 1. So I can say something like, okay, we're turning left, we're turning right, we're doing nothing, or we're pressing on the button or doing nothing. Like there's lots of ways we can sort of go about that. So we'll return an I, And so we get our sum, and now we need to activate it, which this is the maybe sigmoid function. Now this doesn't actually require like a self type thing. So I might want to just do pub function. I might want to do something like this. Have it be private out here. No, I want it to be part of this. We're going to do function activate, but it doesn't need access to self at all. It just takes in the sum, which is going to be an F32. And we're going to return an I8. So I think we're just going to say if, and then we have to make a decision here. So if the sum is greater than like 0.1, then we're going to return 1. Else if the sum is less than negative 0.1, return negative 1. Else, return 0. So then we self-activate, hand it the sum, and return that. Okay, so now in the individual, okay, I'm not doing anything with the input count. We should make this public. Okay, we're getting somewhere. All right, so I need in our entity, we have, okay, so we have the aim rotation there. So your aim rotation, I just can pass it in. So it's going to be the player aim rotation. Okay. Zilby, you're here. Okay, no more errors, no more problems. All right, back to individual. Okay, we play. So this is take a turn. So make the guess, right? I guess like I want to keep the to-do there. So we're gonna do our guess is gonna be equals to self dot. Okay, so we need two things, right? So we have the aim guess. So aim guess. What is it? Rotate. This is rotation guess. Equals self dot rotate perceptron dot guess, and then we need to pass it inputs. And so the inputs for this, the inputs equals, okay, so it's going to be, we want to make sure that this is the right size here. Okay, so game info. So it needs to be, we need to be consistent no matter what, but I guess we're going to be consistent for both of them because I'm going to create this inputs once and hand it to both of the perceptrons. And then that should be all the consistency that we need. So we have R, X, and Y, right? So that's going to be game info. So our position dot X, oh, but okay, there's another thing here. I can't just hand it whatever position I want because we need to make sure that each of these numbers are a number between 0 and, or a number between -1 and 1. So essentially we need to normalize all of this data going in. So I can normalize the positions, and that should work, I suppose. As long as it's consistent, then I think that will make sense. So I think so. Let's let our position then we'll have our position dot X, our position dot Y. Okay, so our first inputs. Then we have our rotation, let's say. How do I normalize that? That's going to be a number between 0 and 365. No, 365, 360. I could probably just divide it by 360. And that would work, right? I mean, there's no normal... Yeah, there's no normalize off of just an F32. So I have to aim rotation divided by 360, I think, and that will turn it into a percentage of what that is. And I want to say that it's going to be a number between 0 and 360, but I could already be a number between 0 and 1, or -1 and 1, maybe. I think that's the difference between radians and that. I don't know which one I want to store as. Obviously this is a huge question mark of like, is this how I'm supposed to do that? I don't know. We'll figure it out. Let's put a debug in here so we're aware. So rotation. Okay, so then we have a rotation. So, okay, for first 3 of 7. So we have position, position, rotation, and then we want our target position. Okay, so and then we need our target velocity. Okay, 1, 2, 3, 4, 5, 6, 7. There we go. Okay, I think that's everything. Now the bullet velocity might be interesting too. That might be really good for us to hand it as well. And I don't know how to turn that into a number between 0 and 1. Like if I figure out how fast it could possibly ever go, then I can divide by that and normalize it that way. So I'm just gonna ignore it and it's gonna figure it out. Maybe. We'll see. Okay, so we have our inputs. And we're going to hand it a reference to the inputs. And that gives us this guess, which is an I8. I need to convert this guess into a command. ZK, hello. Good afternoon. How are you doing today? Ooh, so what if I... Oh, the command should probably be a part of the main game. So... Did I do this right? I am in source, yeah. Yeah, source command. Okay, so command, we have rotate left. We have rotate right. And we have fire. And then we probably should also have like a nothing. Like we don't have a command right now. Doing good? Excellent. Okay, so then in the individual, so I need to turn this into, we have a rotation guess. So our rotation perceptron gives us a number, gives us an I8, which we know is going to be a number between -1 and 1. So I probably want to match this. And so if we're going to have, okay, so if we have 1, then let's say we're rotating right? So we're going to return a command. Oh, wait, can I go back? Can I go out? Can I go like suit? Oh, I can't go backwards, can I? Do I not have access to that? Or wait. Okay, your pub. Is your target still on the screen with side of the screen and is fixed X position, but you alternate? Yeah, so I think it's, do I still have it running? No, I turned it off. Oh, and it's probably not gonna work right now. But yeah, it's basically just going up and down, and it's always on screen. It never goes outside of it. How do I get the command out of this here? I don't think I can I? I'm gonna have to put the command in this crate and then we pass it back. Okay. So I want to move the command to the bot source into there. And put that in there. Then in individual, import create command. Okay. All right. So if we're 1, we'll rotate right. If we're -1, we want to command rotate left. And if we're 0, we want to command nothing. You won't know what this is, so this is going to be a everything else, and then you should be unreachable. Okay, so that gives me a rotation guess. Okay, good. Rotate left, right by how much? Good question. I don't know. I think we're going to leave that up to the game to deal with. So basically, from the way I understand it, which I could be wrong, is it's just going to figure out and learn, right? And the way we would learn is like we press the game and it's like, ooh, that was too much. Okay, that's too, okay. And we sort of like, okay, we need to tap, tap, tap. So the game will implement the amount. Basically, it's like, am I holding down this tick? Am I holding down the button for rotate left? I think that's what it is. And then we're gonna have our fire guess. Okay, so in rotate perceptron guess, and at the inputs, okay, and then you're gonna be, so if you're 1, command fire, and if you're everything else, command nothing. That'd be cool, like emulating. I guess like I'm trying to like in my mind use buttons as a mental model for what it's pressing, but like there's no actual like buttons that are mapped on the keyboard. Like I can't play this at all. Only the bot can possibly play this. I could use the exact same thing though, right? Because I could say, okay, command, if the left button is like, if the left arrow button is pressed down, that command is being fired by the player. Like I could do that. Okay, so then here we're gonna have a series. Okay, so instead of a vec2, when we play, I probably want a vector of commands that we're pushing out. Like there's multiple commands that are happening. Now, right now, there's only 2 things that can happen. So I could just do this, right? I could just say this is an array of a command, and there's 2 of them. I don't know what better I want to do with this. Because if I can't access the parent structs types from here, I wonder if I could, if I like add that into the, I wonder if that would end up being kind of like a recursive cargo.toml. I don't want to cause that. That would be bad. Okay, so when we guess, okay, so when we play, this is giving us Okay, so I am calling play here. I'm iter mapping. I'm not setting this equal to anything. So this is going to be let our commands equal to this. Oh, and you need to know what this is. So this is going to be a collect into a let's just turn it into a vector of command. Okay. Oh, I see. I did this wrong. Okay, so you're going to be a vec of command. So for this individual, no. Okay, so it needs to be like a vec of vex. It's not fun. Okay, so oh, it can't from iterator for that specifically. Okay. So it's going to be a vector of that. Mismatch types expected to struct. Okay, and then they need to fix you. Okay. Okay, so now I get the two commands out when I press play. So it's not going to be aim anymore. It's going to be our commands. Okay, so we got two commands out here. Could the game learn by observing a human player play, saving the commands left, right? So yes, it can, with some caveats. From my very like sort of basic understanding of neural networks and learning, what I could do is I could store data from every frame of like what's happening, or maybe like every 10 frames or something like that. Or maybe every time you hit fire, we store that data. And then I could write code to take that data, label every single line, and then say, okay, train it. And then like do like a training. So that would be the one that we're doing right now, I think, is a form of unsupervised training. And then what you're talking about is a form of supervised training. So absolutely, it can be done that. But then obviously you have to wait. You have to play the game, take that data, do stuff to the data to make it trainable, train the bot, and then let the bot play, and then hope that it's learned well. This one theoretically does it, retrains itself every single time, and then does it again. So it self-trains. That's the idea. Okay. Now this is like setting the force and firing here. So there's a bunch of things that were like, okay, I'm returning the bullet too. Okay, I'm looping. Okay, so I'm looping through stuffed up bullets. Okay, so all right, time to go. interesting. We're gonna have to change all of this. Oh no. Cause like this entire thing is set up with the idea that we fire at the first frame of like when the players are able to, but now I want it to like rotate around. And so that changes things around a little bit. I think we're gonna have to rip out all of this and replace it. I wonder if we can, okay, let's, this is the only aim. This is the only problem. Okay, so I'm gonna just comment you all out there. Let's get our thing actually rotating and make sure that that works the way we expect it to. So we need, okay, so we need a player. If I do, okay, so if I don't do anything for update, so the players just sit here. We have our target bouncing up and down. Okay, so our target's bouncing up and down. Here in our draw, okay, so I want to draw the players, but maybe the players should be, okay, they could be a circle still, but also as part of this, I want to draw a line for the aim that they have. So if I have the, like, aim equals entity what are you upset about? Okay, entity dot I have so many. Oh, wait, no. Okay, I took out most of my. Okay, aim rotation, and then I want to. I want to get this from, okay, so I want to vec to from angle. Okay, from angle pi, rotate by something. Okay, so from angle, and then we hand it pi. And then we rotate by entity, aim rotation. And then I want to draw a line. Oh, is there no line? Oh, wait, I can do a mesh. Mesh new line. There it is. Okay, so context. Okay, our points. So we need a points of where we're starting from and then where we're going to, right? So that's going to be our starting position is going to be our position of where our entity is. So that's going to be entity, and then what exactly are you looking for? Point twos. Okay, so it's looking for 2.2s, which maybe a vec2 would be able to go from that. Zenith macOS version, I think it's the latest, whatever the latest is. Oh, which Sonoma? I've not really been paying attention to the names recently. So whatever the latest is, I think that's what I have on this system. I get confused but sometimes because I have multiple. I have like another system for my day job, and I don't think I've updated that one yet. Okay, so if I do updated position, and I copy that in, and then I want to take the aim, and so I want our aim. So, okay, our entity position plus aim I want to multiply this by like 5. So we have our aim. No, points. Then we have our width. So let's do like, I don't know, 2 pixels. And then our color. Let's do color white. Well, I guess we have this. We can question mark you, right? Yeah. Mismatch types found expected. Oh, you needed vec2. Oh, and you found it F32. Oh shoot. Do I want to just rotate by the rotation here, not by pi? Let's try that. Let's see if that like has any kind of making sense. No code actions available. Oh, because it's okay. It's uppercase color. Okay, and then we're going to do a canvas draw line context, right? No. Draw params, which I don't have any. Okay, there's no errors in the project. So theoretically, we're not running anything. So I should see something with a line in it, and they should all be the same. That may not be far enough out. Let's try for this line. instead of multiplying it by, let's try multiply it by like 500. So I just want this to be a really large line so I can know whether or not it's a, okay, there we go. So this is, that looks so stupid. This is the aim line that we're starting with, I think. Or I could be off by 90 degrees. It could be off by 180 degrees. It could just be completely off. I don't know. But that's that seems maybe absurd. Let's... Okay, that's a little bit better. We have our aim line. Okay. So now when I update you, I think I would just have to get rid of all of this. Okay, so let's skip the learning part right now, and let's just say like there's no training yet. I just need the guesses, right? So I need to go through the entities. So we need to for entity, I need to zip them together, right? So we have for the player and the individual. So players, we'll get an iterator, and then we need to zip in self dot bot population. Can I give this an iter too? Yeah, so I don't own it. I don't take ownership of it. Okay, so now I have a player and the individual. I want to make a guess. So to make a guess, so we're gonna get let commands individual we play. Okay, so we need the game info. Okay, so our position. So we have our player position. The arena size. We have self dot width. Right, that's where we have this thing. Okay, next up, the target position. We have that here. We need the target velocity. We need the target size. The bullet position. Okay, so the bullet position. So I need to zip in. Okay, so we have our player, individual, and then bullet. Okay, so then our bullet position. And then finally, last thing, the aim rotation. So that's going to be the player aim rotation. So we get the game info. 8 arguments, but 7 arguments. Okay, what am I missing? Bullet speed before rotation. Okay. Oh, bullet speed. Yeah, right here. So oh no. That's we have this here. Okay. No? Okay, so we have player position. Okay, so bullet position. Then our aim rotation. I don't know why that one specifically is giving me the types. Okay, then we have our game info. We pass it you. And then we get the command. And so then we update you. So we need, this can't be an iter. This is going to have to be an iter mute. That gives us the ability to mutate the player. Okay, so let's say we match the commands. We have to iterate through the commands. So for commands and commands, let's match the command. Okay. Rotate. So on rotate left, let's just say that our player dot aim rotation minus equals to like 0.1. I don't know if that's a good, let's make it really large. Let's make it 1.0. Rotate right. This will be player dot aim rotation plus equals to 1.0. Fire. We're going to kick the bullet. I am not going to do anything right now with this, so debug attempting to fire. I shouldn't actually print that. We might get this a lot. I will just do nothing with this right now. And nothing is also, we do nothing with this. Okay. So now I'm not training. There's no learning happening, but it should be guessing, which means that it should be like rotating left and right randomly, based upon the weights that are sort of in there. I want to see whether or not that works because we wrote a lot of code and I have no idea. It doesn't look like it's doing anything. But I also don't know if that like makes any sense, if any of this makes any sense. I'm now also not sure that the rotate. Okay, so are you happy? Are you happening? Okay, so game info. Let's debug the commands. This can't possibly go wrong. Oh, command doesn't implement debug? You're right, it doesn't. Okay, I am curious. Are we going to see just a ton of these, which is what I want? We're not seeing, oh, we're not seeing anything. Okay, well, that would be a problem. Okay. So you're never doing the thing. Why are you never doing the thing? I guess we'll have to walk through this. In our main library. Okay, so we create a new population of bots. When we create new, we actually create the population and it's doing its thing, right? Okay. We create our entities. Okay, we create a target, create a bullet. We create our players by going through and we map through all the individuals. We ignore what they are and we just say, okay, here's where you are and then here's your size. And then we start the target moving. In update, I want to get each individual. We're iterating through the bot population of individuals. Oh no, I feel that's wrong. I'm asking each individual to play. I guess, first of all, is this happening? This might be a good... Is update happening? This will be a fairly quick... Yeah, okay, so that's happening. Okay, we loop through here. Now I want to see... let's debug. Okay. Individual. This will be another quick quit if it works. No. Because there's no bullets. There's no bullets. Oh. There's okay. I know what's going on. When I zip in the bullets, there are no bullets. So it can't actually get... Oh no. Okay. We don't know. Okay, so game info. We don't have any bullets to give it. Because they don't exist yet because we haven't fired yet. So I need to not zip in the bullets. So when I do that, then this just becomes player individual like that. For game info, we're going to need to either not bring in the bullet position or make this an option. There is no bullet position. We know what the speed is though. Okay. Now you were okay. So an update. Okay, when we try to update, you need to make sure that we get the bullet position out of here. So we need to extract out. So we need to do let. I mean, I could just unwrap it at that point in time. Let's expect it. We must have bullet position when we do the global update for training purposes. Okay, so if we do that, now if I run this, bullet position not found in the scope. This is the main library. Oh, yeah. Then you are a none. Ooh, okay, there we go. Let's get rid of that that debug. Okay, so this is all. Hey, I thought I got rid of all the debugs. Bot source individual is debugging. Line 71. Oh, that was its rotation. Its rotation is, okay, 1.251, -1. Okay, that's not too bad. That's like close to 1-to-1. There might be some like random weird little problems, but okay. Now this is a whole bunch of them. Let's say I only want to draw out. If I only want to draw the first one, I guess one easy way to do this, we're not updating. I'm just going to make it so that there's only one of them in here. Okay, so if we do that, that's a pretty fast movements. We can see that we're constantly rotating. Okay, so we have a lot of rotate lefts. I'm not seeing any rotate rights. But that might be where training stuff. Oh, there's a rotate right. Okay, perfect. So it's choosing one of those things. So it is guessing. Okay, so also in individual, I could swear for, was that in the perceptron? No, that was in the individual. Okay, yeah, I don't need the commands there. Okay, so then let's have a global rotate amount. So rotate amount. That's gonna be an F32. Let's do like 0.01, a really small number. And now, let's see. I'm just in a normal for loop, so I can just do that in here. I'm not in anything special. So I want to now do, okay, your minus equals self dot rotate amount, and your plus equals self dot rotate amount. Okay, let's run this again. Ooh, okay, so now that feels like a more appropriate attempt to rotate it. It's always rotating right. It's always rotating clockwise, which I think is right. I don't have any like rotate velocity or anything else like that. I think that's fine. Maybe. I wonder if I want to, at the beginning of each entity, update it and reset the no, the rotate is the amount. Well, okay, let's I guess we'll not worry about that right this second. Oh, it's 4:36. I have to end. Okay, so where did we leave? Where have we ended? We've implemented a very basic neural network. We haven't started training it yet, but we've set the seeds in motion where we can train it soon. We've redone our update function, so now we have a single population member, and it's there. If we put the population back, and make it so we have 10 of these again, we can see all of the, yeah, they're all rotating different amounts. Some of them are not rotating at all. Some of them are rotating a lot. I think that sort of makes sense. And it's all based upon whatever was passed in, right? Because the weights are never really, yeah, it's okay. That one like changed to stop there. It's like based upon where this is right now, because that's and their own rotation that changes like what it's trying to do. So that's fine. Next steps for this, we want it to fire, give it the feedback, and then see if it trains. So that is going to be what we're doing tomorrow afternoon. We're gonna see whether or not all this hard work pays off and we get it to actually start training and doing its thing. So fun times. We're really close to like hopefully having like a bot that learns. So this will be fun. All right, absolutely, Jim. Glad to do it. Thank you all for hanging out with me today. So let's see if we can get this all added in. All right, so we added perceptrons to the individuals. And let's go ahead and push that up. If you all want to take a look at this or play around, then I have the code right here. Stormy, hello. How are you doing today? Yep, I was just pushing as soon as you saw it. So I'm putting this on the main branch right now. This is all just exploration code anyway, so it's all there. Stormy, I am just leaving, so I guess it's like a hello goodbye type moment. Okay, so as a recap, tomorrow afternoon, we are going to be sort of wiring up the bot so that way the bot learns, because the bot can fire. So we need to add in the ability for the bot to fire with a command, and then we need to implement learning and like have the bot actually get feedback from how that fire went, and then just repeat, rinse and repeat, over and over and over and over and over again. Oh, you didn't know that I stream? Oh, nice. You were watching the YouTube tutorial. Nice. Yeah, so I stream right now for the rest of this week. I stream twice a day, once in the morning at 7 a.m. Mountain Time, and then once in the afternoon at around 2:30 p.m. Mountain Time. But then next week, everything changes, and I'll know exactly what that change is going to be later this week, hopefully. hopefully within the next couple days, because I don't really have much time for the rest of the week. But if you want to take a look, here is the schedule for the rest of this week, which I didn't stream Monday, but I guess it's past that, so it doesn't matter anymore. Fellow Mountain Timer. Oh, nice. Okay, excellent. Then you know what time that is. So yeah, that's everything. I don't really have anything else besides tomorrow morning we're continuing with the Git project. So if you want to watch me create my own version of Git, then we'd love to have you. So with that, I hope you have a great afternoon, and I will see you all next time. Bye.